Hi guys, Shouvik here. Welcome back to YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes. So today we have this question: rabbits in forest. So on that question, what they have given to us, there is a forest with unknown number of rabbits. So there can be like we don't know how many number of rabbits there in the forest, and they have given like we have the opportunity to ask in rabbits in any in rabbits how many rabbits have the same color as you, how many rabbits have the same color as you. So that opportunity we have it. So that opportunity we have it. So what they have proven given the liability to us. So there can be unknown number of rabbits in the forest, but we can ask any n rabbits how many rabbits have the same color as you. So please take a note, like that is of exclusion of himself or herself. So exclusively the rabbits which we are going to ask how many rabbits of same color as you. So let's suppose there are five rabbits of color red, and we ask any of arbitrary red color rabbits how many rabbits of same color as you. This rabbit is going to tell us 4, because excluding him there are 4 more rabbits. There are 4 more rabbits which are red colors, red colors. So that is, please take a note on these points. Excluding himself or herself, that particular rabbit, this rabbit is going to tell the answer. So if there are 5 red rabbits, this rabbit is going to tell us there are 4 red rabbits of same color as me, exclusive myself, there are 4 red rabbits in the forest. And finally they have given us an answers in an integer array answers, where answer size is the answer of the ith rabbit. So every rabbit is going to tell us an answer. So that answer array has given to us, the answer array is given to us what is the same color rabbit excluding him or herself exist in the forest. So that answer array is given to us. So now we given the array answers, now we have to return the minimum number of rabbits could be in the forest. So we have to return the minimum number of rabbits could be in the forest. So if we can iterate on the first test cases, so there you can see first rabbit tells there are one more rabbits of color as which color I possess. Similarly, this rabbit tell us that there could be one more rabbit that could also possess the same color as me, So here you can see what they told. The 2 rabbits that answered 1 could both the same color, say red. So first rabbits point to the other rabbits which is in the forest of red color, and similarly for the second rabbit pointed to the first rabbit which is also same color. So it is something like this. If I can go to my OneNote. So let's suppose there is a red rabbit, so we ask. So please take a note what they have asked for. They basically asked for minimum number of rabbits. So we should be kind of greedy, so that we can reuse the rabbits in the answer, in the given answer query they have given. So that like if the first rabbit, so if I now can go to the OneNote, so red rabbit is going to tell us the answer as 1. So that means this rabbit is going to point to this rabbit. So there is one more red rabbit of same color as me, and for this rabbit also we are greedy. There can be another red rabbit. So this red rabbit can be point to this rabbit also. So let's suppose we can consider it as a blue color. Then on that case, this rabbit is going to point to this another blue color rabbit, and there can be this rabbit is point to another any arbitrary rabbit, right? But we are not going to go with this arrangement, because on that arrangement we could have more number of rabbits, but we have to tell them what is the minimum number of rabbits. So on that case, if we can do a little bit greedy things, let's suppose we have 2 red rabbits. First red rabbits point to this and tell the answer as 1, and this red rabbit point to this red rabbit and tell the answer as 1. Yes, we can do. Then on that case, on both the queries, 1 1 on the first 2 queries, how many rabbits exist in the forest? 2. For both, the answer is coming as 2. Like this way, we are greedy. We can do something like this. We can consider this rabbit as a red, and it points to some arbitrary red rabbit, and we can consider the second answer is still as a blue, and it can point to any arbitrary blue rabbit. Then on that case, for this query we have answer 2. For this query we have answer 2. But no, we are not going to go like this way. We are going to go with this arrangement, because on this arrangement we are going to super greedy to not to choose any rabbit until the same quota of rabbits we are going to exhaust it. If we are exhausted of the rabbit, then we are very open to take other rabbits. But if there are altogether one, we have first one and then 2. So if that is a 2, then we are very sure that we are not going to satisfy. We can't tell this, we can't consider this is a red, and for this red rabbit there are two more red rabbits exist, two more red rabbits of same color exist. No. So this is going to be, we are going to violate the principles, because excluding himself, excluding the current rabbits, are there any two more red rabbits? Are there any two more red rabbits? So if I consider this rabbit as also a red, so if I consider all the rabbits whom we are going to ask for, so this red rabbit is still excluding there are one more red rabbit, right? This tell us one. So if I consider this as a red, so this red rabbit still there are two more red rabbits. For this it's valid, but for this it is going to be invalid. Because for this rabbit there are then two more red rabbits, but that is not the case. For them there are one more red rabbits, which how we can satisfy them? We have satisfied by themselves only. So this point to him and this point to him, they are point to each other, so it is bound to take another new color. So let's suppose it took a color blue. So excluding myself, there are two more blue rabbits. So there are two more blue rabbits. One is this, another one is this. So how many then total rabbits? 5. 2 here, 1 here, 2, 3. 3 blue rabbits and 2 red rabbits. 2 red rabbits and 3 blue rabbits. As simple as that. See, here you can write the entire gist of the things. They mentioned exactly same things. So they have took 5, 3 that answered by 2 that didn't, and for this 1, so for this 2 we got 3, and for the first 1 and 1 we point to each other, right? So for this 10, the answer is 11. How? Very straightforward. If you understood this, you can tell by yourself. So we have choose any arbitrary rabbits, and it's still, let's suppose it's colored as red. It's told us that there are 10 red rabbits like this way. There are, let's suppose that is the 10th. That is the first, second, third, like this dot, like that is the 10th. There are 10 more red rabbits. So this is also red, this is also red, this is also red, this is also red. And then we are trying to reuse for next query. If they are also tell the same color, if they are also tell the same number, same, excluding myself, there are 10 more red rabbits. First told us there are 10 more red rabbits, 10 more rabbits which are same color as me. Second also told there are 10 more red rabbits, there are 10 more rabbits which are same color as me. We are going to reuse, because for one case we have point to each other. First points to second points to first. So for this also we are trying to do the same things. So here you can see. So when we are going to ask the second rabbit, we are going to ask the second rabbit. This rabbit also tell excluding myself. So maybe this is this rabbit. Maybe this 10 is coming from, we are asking from any of this rabbit. So this rabbit can tell excluding myself there are 10 more red rabbits like this way and it's point to this rabbit also, right? And for third one, let's suppose the third rabbit is this rabbit. It is also doing the same. It is point to this. We are super greedy and it points to this also. So excluding myself, there are 10 more rabbits which we just able to highlight. So for 10, every answer is point to able to answer any of the rabbits that we already answered. So on the same set, for the same set. So for the first query, we don't have the liberty. We have to create the rabbits. We have to make the forest to that number of rabbits, so for sure. So for first 10, excluding himself, there are 10 more red rabbits. So there are total of 11 rabbits. Fine. So for second query, we are not going to use. Because there are 10. Second rabbit also going to tell us 10. So that means excluding himself, there are 10 more red rabbits. Maybe this is this rabbit, and it is pointing to another 10 rabbits of same color by the already 11 rabbits that we spawn on the forest. So for the second query it is 0, and for the third query also it is 0. Similarly, similar fashions. Maybe on the third rabbit is this rabbit, and it is point to the another 10 rabbits that we just spawned the first query. So when we just have to increase the number. So let's suppose we have 1 and 1, right? 1 and 1. So we are very greedy. First rabbits red, and there is a red rabbit. So for second rabbit, maybe we choose this, and we are able to point this, right? But for this rabbit, as we use, So this rabbit already point to already existing rabbit. This rabbit has point to this rabbit. So for another one, for this one, can we tell it is a red? No. Then on that case, for this red rabbit, there are already 2 red rabbits. So excluding him, there are how many red rabbits? There are 2. So we are violating our conditions. So on that case, we have to spawn a fresh color rabbits in the forest, and we can mark another rabbit. We can associate another that number of rabbits excluding him is exist in the forest. So on that case, how many rabbits? There are 2 plus 2. So for first one, there are 2 rabbits, and for the second query, we are not going to use any, and for the third ones, we need to spawn 2 more rabbits. So on that case, it is 4. On that case, it is 4. And let's suppose if a rabbit going to tell us answer as 0, so that means excluding him, there are no more rabbits in the forest with the same color. So if that is the 0, then we anyhow have to spawn a fresh rabbit. So I am just giving you the boundary cases. So if a particular answer is going to tell us, particular index answer is going to tell us there are no more rabbits of same color, then it is going to we have to spawn a fresh rabbits, and no other rabbits we are going to reuse with this particular set. So if the answer is 0, then we have to increase our answer to +1. If a particular answer query is giving us a 0, then we have to increase the result that we are going to return, minimum number of rabbits in the forest. We have to increase +1 if they are at 0. And if we have the liberty to reuse, then we will do. And how we will reuse them? I think from the 1 case you guys are able to understand, but if you still not, then maybe just write for 2 case. So for first rabbit, there are 2 more red rabbits. And now, so we have allocated total 3 rabbits in the forest. So these configurations. Now for next query, how many? So this rabbit is pointing, there are 2 more red rabbits of same color. So maybe we are going to choose this rabbit and point to other two. Yes, I am super greedy. So for this query, answer is coming as 0. Now for this query, I am choosing this rabbit and point to this and this. So for this query also, answer is coming as 0. For this query, answer is coming as 0. And for the last one, we have already exhausted of the twos bracket or the twos bracket. Till now we are following the twos bracket. We have exhausted because we have already pointed everyone to everyone. So here we have to spawn a fresh blue rabbits, and there are 2 more. So for last query, we are bound to spawn 3 more rabbits. So I think the intuition should be built on your brain. So now if I can ask you to write the same things in terms of code, then how the pseudocode should be coming first to your brain, how the pseudocode should be first come to your brain. So we definitely need a default dictionary or a kind of frequency map. We definitely need, and we have initialized to a default dict of int. So we need how many 2 color rabbits. Answer of I is 2. Then there are 1 red rabbit we have spawned, which is pointing to other 2, red rabbits. Pointing to other 2 red rabbits. We should need when we are spawning these first red rabbits, how many red rabbits already for this particular first spawning we have spawned. For this particular spawn rabbit, how many reusable rabbits we are spawning. So that count we are storing in our default dict, because if we are going to encounter the similar count of rabbit, then we will do the same things. We are trying to rebook of the already existing spawn rabbits, and if we don't have the liberty, like everyone has pointed to everyone, if that configuration is hit, then on that case only we are going to spawn altogether a new bracket. So we definitely need a default. And now how should our algo should be looks like? This is too much. It is moving from here and here. Yeah, so we are definitely iterate to our answers, right? We will definitely iterate to our answers. And the first very case, if this each, the current answer is going to tell us as 0, then we are very sure we are going to increase our answer to answer plus one, right? Because we don't have the liberty, because for 0 we have to spawn 1 fresh rabbit every time. Very intuitive, we just also explained. Else case. How now actually the beauty of our algo is lying here. So if my dd of each has some value under this else block, I am writing if my dd of each has some value, so that means we have the liberty to reuse. So on the first case, when we are assigning spawning a first red rabbits, which is pointing to two extra red rabbits. So for these two, we giving the two powers, two reusable powers to another two rabbits in our default route. So if we have this power, so when we are landing to these two, so these red rabbits, we can point these rabbits to the already spawned rabbit. So our default tick should have some value. So in that case, do we going to spawn more rabbits? No. But as we are reusing a value to our default tick, we are going to bound to decrease its count. Right? Very straightforward. But if that is not a case, if our default tick is already has that particular same color rabbit spawning has 0, or if it is a very first start, then on that case, how many rabbits we have to spawn? That is of each plus one for sure, because this rabbit is telling us there are two more rabbits of same color, so each for that many rabbits of same color, plus one for himself or herself, because we know our query, our answer is going to be exclusive of him or herself, so we have to add plus one to it, and we have create the power to reusability of our default tick to how much, because for the first query for these two, how many reusable powers we are generating, because excluding him or herself, there are two more red rabbits we can reuse. If you are going to encounter answer of I as 2 in future, you can reuse how many. So there are nothing but answer of I, that is nothing but that we have for answer of I as 2, we are spawning two reusable rabbits, which I am repeatedly highlighting, guys. So here actually the beauty of this algo line. So for dd of each, we are just storing as each, because we have the liberty to reuse another that many red rabbits, and when on second red rabbits, when we are landing to this particular red block, we are going to decrease its count, and like this way, when we all together use, for the first one we have create 2, second one we have reused 1, third one we have reused 1. Now our default tick of each is not going to go to this block, and it is again going to go to this else block, and it is going to spawn, let's suppose another here. From here it is going to spawn another of this blue group, right? Like this way, this algo should finally you can return your answer. Yes, it is as simple as that, guys. Now I can quickly go to the code iterations. I wrote exactly the same code. Yes, so yes, I have initialized my default dictionary, and I have initialized my answer, and I am iterating to my answers which they have given to us. And if we all know, if our each is 0, then what are you waiting for, man? Increase the answer to be plus 1, because we don't have to do anything. And if dd of each has some value, then reuse. This is for reuse. And if it is not, then spawn at least each plus 1 fresh rabbits in the forest. Yes, I will do. And store your dd of each with each counts, because each is that many reusable rabbits also. If we are going to encounter future query of same count, then we are going to use from this each. So that block is this, and we are also decreasing on that time. So when you are spawning each plus 1 rabbits in the forest, also make each rabbits to be in the reusable frequency map, and finally we are going to return the answer. Yes, guys, the question is as simple as that, but the mathematics, the intuitions you have to build, I personally feel it's quite awesome. I really like this particular question, and the time complexity for this particular question, it's, tell me guys, we are able to do our entire job in big of n, only a single iterations, nothing more than that. And on space perspective, we are carrying a reusable map, which is going to take a big of n space. Yes, guys, it is as optimized as that. So my submissions is kind of like 100% faster of all the Leetcode submissions. It took almost 0 milliseconds, and I personally feels that can be the most optimal time and space complexity you guys can achieve of. So yes, guys, so the question is as simple as that, and if you guys are able to understand till this point, I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos who are also preparing for top product based company and brushing up their DSS skills, and please turn on the notifications so that when we are going to live with our next video, you are going to get the notification as soon as possible. So that's it, guys. That's it for today. Bye, guys. Let's meet tomorrow with another beautiful question. Bye.